Now, when we've got tangents and normals, because the normal is sort of inside the curve, if you like, or passing through the curve, sometimes a normal can actually meet the curve again. And we might be interested to know where it meets that curve. So, the question we're going to ask is, if we have the curve xy equals 4, and we look at the point x equals 2, find the equation of the normal. Where does the normal meet the curve again, if it does? Well, let's have a look at a picture. Y equals 4 over x. What does this look like as a curve? Okay, if we have a very large value of x, say 100, then 4 divided by 100 is very small. So we've got a little bit of curve down here. If we have a very small value of x, say 0.01, then 4 divided by 0.01, 0.01 is 100th. So 4 divided by 100th is 400, very large. So for very small values of x, we've got a bit of curve there. And we can join it up like that. Now, if we take negative values of x, the same thing happens, except we get negative values of y. And so the curve looks like that. Notice we do not allow x to be 0 because we cannot divide by 0. So there is a hole in this curve. There is a gap here at x equals 0. Well, here's the point, let's say x equals 2. There's the point on the curve. There is the tangent to the curve, and there's the normal to the curve. And as we can see, this normal goes through there. So the question is, where is it? Where is that point? So, first of all, let's establish what this point is up here. So we know that x is equal to 2 and that y is equal to 4 over 2 equals 2. So our point is the point 2, 2. Next, we want the gradient of the tangent in order that we can find the gradient of the normal. So here we have y equals 4 over x, which is 4 times x to the minus 1. So I'll differentiate that. dy by dx equals minus 4 multiplying by the minus 1, and then taking 1 off the index, that gets it to be minus 2. So we have minus 4 over x squared. X is equal to 2, and so dy by dx is minus 4 over 4 is minus 1. So, what have I got? I've got the point, 2, 2, and I've got the gradient of the tangent. And remember, tangent and normal are at right angles. So for two lines at right angles, m1 times by m2 is minus 1. I know the value of this, it's minus 1 times by m2 equals minus 1. And the only number m2 can be there is 1. So now I have got, for the normal, I want its equation. I've got the point that it goes through, which is 2, 2, and I've got its gradient, which is 1. So I can write down the standard equation of a straight line. Y minus y1 over x minus x1 is equal to m. This is my x1, y1. And I can substitute those in, so I have y minus 2 over x minus 2 is equal to 1. Multiply up by x minus 2, so we have y minus 2 is equal to x minus 2, and so y is equal to x. And so now we have the equation of the normal, y equals x, and we have the equation of the curve, x, y equals 4. Now, where does this line meet this curve? That's what we're asking ourselves. Where does the normal intersect the curve? At the points of intersection, both of these equations are true at the same time. So that means I can take the value of y, which is x, and substitute it into here. So therefore, I have x times by x equals 4 at these points. In other words, x squared is equal to 4. And if I take the square root, that will give me the value of x. We might think that's just 2. But remember, when you take a square root, you get a plus and a minus. So we have x equals 2 or minus 2. And so if x equals 2, then y must be equal to x, so that tells us y equals 2. Or, and if we take minus 2, y is equal to x, that gives us minus 2. And so our 2 points are 2, 2, and minus 2, minus 2. Those are the 2 points where the normal meets the curve. Notice this is the first point that we started off with. And indeed, when we're doing this kind of question, the point where we started off with always is going to be a part of the solution. So, we've dealt with applications to tangents and normals. We've seen that in order to find the gradient of the tangent, you differentiate, substitute in the value of x, and that gives you the gradient of the curve, and hence the gradient of the tangent. And the other relationship that we found was that a normal was perpendicular to the tangent, and that the product result of multiplying 2 gradients together where the 2 lines were perpendicular was minus 1. And that's an important relationship when we're looking at 2 lines that are perpendicular, as is the case for tangent and normal.